So in this lesson, we're going to determine where a function is continuous, and then if it has a removable discontinuity, what values would make it continuous. So there's only a couple boxes. One of them is going to talk about domain. Okay. Now, this is something, can you guys focus, please? I got 20 more minutes with you guys. Thank you. This is something that's really important. We're talking about functions being continuous, right? That means no holes, no what? Jumps, and no asymptotes, specifically vertical asymptotes, okay? So if we know what the domain is, you guys listening? If you know what the domain is, that means anything that you're allowed to plug x's into, right? Into the function, and it's okay. So if you know what the domain is, that means that is where the function is continuous. That make sense? That means that it only works where it's continuous. The domain and continuity work hand in hand, okay? So let's talk about some special cases that are going to come up. This is a rational function because it's a fraction. What makes the bottom 0? 1, okay? So do you guys agree, right here, I'm going to say that x cannot equal 1 because the denominator cannot equal 0. We agree with that? We agree with that? Okay. So what does that mean if I plug in 1 into the function? What does that mean about the graph? What exists? An asymptote, because it doesn't cancel, right? The x minus 1 doesn't cancel, so that means we have a vertical asymptote at x is equal to 1. But do you guys agree with me that that 1 is the only number that makes bad things happen? I can plug anything else in and it's okay. So there's 2 ways to write your domain. You guys will see this in calculus. You'll see that the domain is just x can't equal 1, or we'll use interval notation. I can plug in any number I want except 1. So what number is way this way in negative? And then what number is way over there in positive? But I have to skip over which number? 1. So the domain would be negative infinity to 1. And then what do I use? A union. Guys, please don't write your u's like this. Union is a symbol, so write it like a little horseshoe, like that. Union 1 to infinity. Okay. Even roots. Most of the time in this class, we'll only be dealing with square roots, not 4th roots, 6th roots, whatever. But what numbers can we not take the square root of? Negatives, right? So you want the inside of the radical, to be positive or 0. So that means that whatever's on the inside you're going to set it what? What? But how do we say we want something to be positive? We want it to be what? Bigger or smaller? Bigger than or equal to 0 and then solve. So, I mean, you guys are in calculus. I don't need to show you guys this, right? You guys agree I can add 10 and then divide by 4? And if I do that, I'm going to get x is greater than or equal to 5 over 2. because it simplifies. Okay, that's one way to write the domain. What's another way? Which is bigger than 5 over 2, positive or negative infinity? Positive infinity, right? So bracket or parentheses? Bracket, right? Because it's equal. So the domain would be bracket 5 over 2, comma, infinity. Do we ever use brackets for infinities? No. Okay, good. Okay, this last one, because you guys are calculus, this one is super important that we remember. We can never take the log of a negative, ever. Ever. Or 0. So the inside of the parentheses must be greater than 0. So what's on the inside of the parentheses here? Do you guys agree it's 2x plus 1, right? So to find the domain, all you have to do is say, hey, 2x plus 1, I need that to be greater than 0, and solve for x. So we agree I can just subtract 1 and then divide by 2. So that means that x must be greater than what? Positive or negative? Negative 1/2. Okay, so that's the domain. To write it in interval notation, parentheses or brackets? Parentheses, what comes first, the negative 1/2 or infinity? Negative 1/2, right? So parentheses, negative 1/2, comma, infinity. Okay. So you guys are smart. No pressure, but I'm bragging to admin about all you guys. Mr. Vigil, how's calculus going? Great. They all did really well in the first quiz. So I'm going to give you guys some challenging examples right now because I want you guys to be solid later on. So I'm going to start with some easy ones. Determine where each function is continuous. Probably give it a name. Stop. Please stop. What should I do first? Factor. So I'm looking for two numbers that multiply give me 4, but when I add them I get 5. Four and 1, right? So this factors to what? 1 over x plus 4 times x plus 1. Now, is anything going to cancel? No. But even if it did, right now, what makes the inside of this 0? And what makes the inside of this 0? Negative 1. So one way you guys could write the domain is x cannot equal negative 4 and x cannot equal negative 1. What that tells the person reading this problem is the domain is all real numbers except these two numbers. Okay, but I want you guys to be comfortable with interval notation first. Okay, so which number comes first on the number line? Negative 1 or 4? Negative 1, right? Because of the negative. But what comes first? What is the smallest number we can imagine? Negative infinity, right? So negative infinity all the way to negative 1. So the domain would be negative infinity to negative 1. Oh, yeah. Good job, guys. In my head, it was positive 4 when I was pointing at it. But yes, it's negative 4. Good job. No wonder you guys are looking at me like I'm crazy. More than usual. Union. So what would come next? So I skipped over negative 4. Am I going to go to infinity now? What comes next? Negative 4 to negative 1. Union. I skip over negative 1, right? Is there anything else I have to worry about? Infinity. Good. Hooray. That was too easy though, right? That was too easy. These are the ones that, if you guys are in my college class, these are the ones that you guys, as the year went on, you guys got so much better at these. Okay? There's two things wrong with this problem. One of them, we have a square root, right? Are we allowed to take the square root of any number? No. And also, we're not allowed to divide by what number? 0. So I have to pay attention to, number 1, what makes the bottom 0? And number 2, what could I plug into the square root so that way it stays positive? Okay, you guys with me? So let's do the easy part first. What would make the inside of this 0? Negative 3. So right away, I'm going to say that x cannot equal negative 3. Okay. Now, the rule is we want this to be either positive or 0, right? Because you can take the square root of 0 and you can take the square root of positive numbers. So, but what I need to pay attention to is this. X plus 3, just watch before you guys write anything down. Normally you would say greater than or equal to 0 and solve. However, do I want it to actually be 0? Because then I'm dividing by 0, right? So to fix that, all I have to do is just erase that, okay? Because here I can only have it be positive. How do I solve this? Subtract 3. So just x has to be greater than negative 3. If there was no fraction here and it was just the radical, then I could leave it underlined. You guys follow me? Because then it can be 0. So here is one way to write it. Another way to write it would be this. Negative 3 to infinity. Okay. Questions? Okay. Do you guys want the hard one? You guys want to save it till Friday? Friday? Okay, let's do the not so hard one. Does anybody notice anything? What? The x's cancel, good. So what does that mean about my graph? Do you guys remember? If a factor cancels, that means there exists what? A hole. That means that x cannot be good. 0. Because you guys agree if I plugged in 0 here, 4 times 0 gives me 0, right? Now, we still have this radical. Now, this time it's on top. Remember, we want the inside of the radical to be what? Positive or 0. So we want x plus 5 to be greater than or equal to 0. Okay? If I subtract 5 from both sides, that means x is greater than or equal to negative 5. And I should say this too. This is 1.12, right? What we're doing right now. This will not be on your quiz on Monday. Monday, we're not going to do any notes. Monday's just your quiz. Cool? Okay. Now, this right here using interval notation, that means -5 all the way to infinity, right? But there's something I have to remember. X also can't be 0. So I have to skip over 0. Bracket or parentheses? Bracket. So the domain will be bracket -5 to 0. Do I use a bracket or parentheses for 0? Parentheses, good. And then what? Union. Does Mr. Vigil say we could write it like that? No. Union, what? Good. Okay. I'm going to pause here.